The BP Chemicals plant at Gel in Belgium. A modern integrated facility in which several steps of the production of the final products are carried out on the same site. This picture shows the layout of the site. The rectangular area shown on the right-hand side of the picture is the area in which paraxylene is produced. Paraxylene is the principal building block in the manufacture of terephthalic acid, which in turn is used in the production of polyesters. Since the worldwide consumption of paraxylene is very high, this plant is just one of many serving the world market. Any chemical plant must, of course, conform to environmental protection laws and practices. BP uses its resources to ensure that the management is continually informed of the quality of the atmosphere in and around the plant, and for this purpose, invest in the best technology available.
Welcome at the BP chemical plant in Belgium. We are in operations since '69 and giving work to 550 people. The main products we produce is terephthalic acid, isophthalic acid and polypropylene. In spring 2000 we started up a new paraxylene unit. As BP is a responsible organization, the production of chemicals is done with great care towards the environment. This is also confirmed by our ISO 14000 certificate. The first step, of course, is the design and building of an emission-free unit. The following step is to confirm that with emission monitoring. Therefore, we installed in Geel a fence line monitoring system, giving us continuously information about the air quality.
The detection of fugitive emissions of hazardous vapors is an essential part of environmental and safety monitoring and of conformity to legal requirements. Not only can rapid detection of leakages or accidental escapes prevent potentially dangerous situations from developing, it can provide an early warning of plant malfunctions. Here at BP Chembel, Gel, a fence line monitoring system, designed and built by the Swedish company Opsis, has been installed. The system provides continuous atmospheric monitoring of a range of gases, including benzene, toluene, and xylenes, at levels below 10 micrograms per cubic meter of air. The well-proven technique used in the Opsis system is known as DUAS, Differential Optical Absorption Spectroscopy. Here we see the principal parts of the DUAS system. First we see the emitter, which is a high-intensity continuous white light source mounted in a suitable location. This projects a beam of light through the atmosphere along the perimeter of the plant. The light is detected by a spectroscopic analyzer unit, shown here. The analyzer is located in the analyzer house, on the roof of which is also mounted a small weather station to monitor wind speed and direction, as well as air temperature. Gas or vapors which should not normally be present in the atmosphere will superimpose characteristic fingerprints on the light spectrum, and these absorptions are used both to identify the gases and to determine the concentration at which they're present. The software, which forms part of the analyzer system, performs all the necessary calculations, storage of results, and communication with remote computers and data loggers. The analyzers themselves incorporate continuous calibration checking and can be easily validated using known standards. But this is not a requirement in routine operation. In the Gel installation, monitoring takes place along the four sides of the rectangular site, and the emitters and detectors are about 500 meters apart. The emitters are located at one corner of the site, with the detectors mounted on the roof of the analyzer house at the opposite corner. Mirrors mounted on the remaining corners reflect the light to complete the light paths. It's vital to ensure that the components of the system, the emitters, mirrors, and detectors are precisely aligned at all times, so that the energy is maximized. On each of the component mounts, motor drives are used to adjust the position of the head in both azimuth and elevation. This means that any small deflection, for example due to ground movement or high winds, will not affect the light intensity. It's also important to be able to deal with a situation of signal loss in the event of snow or heavy rain, which blocks the light completely. In that case, the alignment automatically reverts to a stored base position, from which fine adjustments are made once the signal is re-established. The weather station is used in conjunction with the measurement of emissions, so that any analytical information produced can be linked to details of wind direction and speed, air temperature and pressure, and other data to help pinpoint the source of the emissions. Here we see some typical screen displays available to the operator. All data is logged and kept securely stored for long-term record keeping. An interesting situation was observed at this site. On occasion, short bursts of benzene emissions were detected, although no other processed products were being emitted. Analysis of the combined analytical and meteorological data showed that this was only occurring when the wind was blowing from the northeast. It was found that the source was a commercial plant some distance outside the perimeter of the BP site. In environmental pollution monitoring, the reliability of results and high uptime are major considerations. It's important, therefore, to keep maintenance requirements to a scheduled minimum. And in the case of the Opsis system, normal preventative maintenance need only be about half a day every 3 or 4 months, and this can be planned to coincide with the maintenance of the plant itself.